Hello everyone, my name is Martin Zikmund and I thank you very much for tuning in to my session about the UNO platform UWP everywhere. So, companies today want to develop their applications for multiple platforms. Ideally, they want their application to run on Android and iOS for mobile, on the desktop, on Windows and Mac OS, and they want to develop their applications for web as well. To achieve this, there has to be some kind of cross-platform application development story. A cross-platform application development is, by its definition, challenging because every platform has different APIs, has different interfaces which we have to use, and there are many approaches, and none of them is ideal because each has some disadvantages and some advantages. So the company has to choose carefully at the start which approach they want to choose. And there is an ongoing search for an ideal solution. The so-called traditional approach to developing cross-platform applications would be to build native application for each platform separately. So if you want to build an application for Windows, you will have to use C# and build it in UWP, WPF or WinForms. If you want to target Android as well, you will need to use Java and Kotlin. For iOS, you will need Objective-C and Swift. And for the web, you will use JavaScript and the many frameworks that are available there. This is, of course, not efficient because you will need a lot of developers, because it's unrealistic to expect that one developer will be proficient in all of these platforms at once. And you will need more time to develop these applications because each of them will take you some time, and as a result your costs will be higher, and even then after your application is released. Whenever a bug is reported, you will have to fix it separately on each platform because it has separate code base. There is no chance for code sharing because there is no middle ground between those. So it's very inefficient, and companies are trying to avoid that if possible. The alternative would be to have one single language and runtime which would then run on all the platforms which are available. One choice would be JavaScript, but that is not native except for web browsers, and it has some performance issues on the native platforms like Windows, Android and iOS. So a better solution for us .NET developers would be something based on C# and XAML, because that's the environment we have been building our applications for years, and we are very familiar with XAML and C#. And the first attempt at this was made by Xamarin.Forms. It's a XAML-based cross-platform application development framework that's rendering its XAML code using platform-specific UI controls. So on Android, your button will be Android button. On iOS, it will be UI button, and it will perform and look natively for the users, which is of course great, but there are some issues with styling and branding, because if you want your application to look great on the user's device, it should have some branding, it should have some animations and nice visuals, which is hard to achieve in Xamarin.Forms. You will need a lot of custom renderers and custom controls to make it happen and to make it look great on all platforms you are supporting. In addition, the XAML in Xamarin.Forms is a simplified dialect of XAML, and it has limited support for templating and styling, which we are used to from UWP and WPF. It has different naming conventions, which is confusing for developers coming from Windows world. That, for example, with property is now with request, and there is also a with property in Xamarin.Forms, but it's just read only. So if you just copy paste your code from Windows to Xamarin.Forms, it will probably not work correctly. Also, in case of background and foreground, you are expecting to have the rich brush class available, so that you can not only set the background to a solid color, but also to some linear gradient brush and so on. But that's not really possible in Xamarin.Forms as well, because you have just background color. Background color is just a solid color, so you cannot add some gradient or add image background to an element, and that's very limiting. And if you want to support these things, then you will probably need to implement some custom renderer on each of the platforms, use platform native UI controls to make it work. And that's kind of daunting task. In addition, Xamarin.Forms is mainly about the UI. So if you want to use some other device-specific or platform-specific APIs like GPS or clipboard or application settings, you need to use a third-party library, or in this case Xamarin Essentials, which is developed by Microsoft directly. And this library then gives you access to these APIs. Of course, that's great, but you have to learn a new interface for all these APIs, because it's not something you cannot reuse your existing skills from Windows or Android on iOS. You have to learn new interface, and that means some learning curve, and that means some additional time you will need to get your application going. If you look at the UI, then you can see that for the same XAML code, the application in Xamarin.Forms looks completely different on each platform. Sure, there are the same controls, but the UI is different. The styling is different, and it's pretty hard to see the consistency between the platforms. And to get that, you will need to use some custom renderers, and that's again hard task to do. Xamarin.Forms team of course has recognized this problem, and they came up with a solution in the form of Xamarin.Forms shell and material visual. This is great solution which allows you to bring material design from Android and take it to iOS as well. Although this solution kind of works, it has also some disadvantages, and as you can see, even though the result looks much more similar than before, there are still some differences. The shadows are different, the margins are different, and again, to work around these issues, you will have to customize the layout. And finally, for the UWP or Windows part of the story, Xamarin.Forms shell is not supported yet, and there is some ongoing effort to implement this by the community, but it's still in early preview, and it's clear that the official team of Xamarin.Forms is focusing on innovating on Android and iOS first, which is sad, and it's a disadvantage for the developers overall as well, because there are many developers in Xamarin.Forms who are basing their debugging experience and dev loop on UWP, as it's the most performant and is directly on Windows. So it has the first-party debugging support, it has the first-party exception handling support, and you can just easily iterate on UWP and then bring your application to iOS and Android. So not having shell and material design there means people will be limited. a better solution comes from the UNO platform. UNO platform is a cross-platform application development framework, which is a port of Universal Windows Platform APIs and XAML to iOS, Android, WebAssembly, and macOS. It's completely written in C# with some bits of Java and JavaScript here and there, which allow for better performance and to communicate with browser APIs, and is striving to achieve 100% compatibility with UWP XAML, which means Windows developers coming to UNO platform will be able to reuse their existing skills and create a consistent UI which will look great on every platform, and it will be easy to iterate the design. UNO platform has been developed by Inventive for 5 years now and has been open sourced last year in May 2018, and is now free and open source on GitHub, so everyone can use it. It's battle tested because Inventive has built a lot of applications with UNO, and those are production apps which are even in the store. So you can be sure that UNO platform will be supported and will work pretty great. And if we now look at the same kind of example as before with Xamarin.Forms, we can see that now for the same XAML, the application looks almost perfectly the same. There are some differences because of different default font, but otherwise the buttons look and behave the same, the text box is the same, and it just is the same experience, and it is consistent. And it's also easy to style, so if you don't like this style, you can just replace it with anything and it will work. The same goes for UWP and WebAssembly, and as you can see, even here the design is the same and it's doing what you expect. UNO platform supports UWP by its definition, that's native support, and Android and iOS are stable now. With preview version of WebAssembly, you can now deploy your UWP application to the web and run it in a browser, which is pretty amazing. And there is now an early preview of macOS support as well, which is looking pretty promising, and it will mean that your UNO application will now run completely everywhere. The philosophy of UNO has 5 main points. The first goal is to leverage existing tools, because Visual Studio is the interface and the IDE we are used to. It will be great if UNO developers can use things like XAML Designer, XAML Live Property Editor, XAML Edit and Continue, C# Edit and Continue, and just develop the same way they have been developing their UWP applications before, and then deploy them to all the platforms at once. The second point of UNO philosophy is to create rich and responsive applications, because users nowadays don't settle with some meager looking application. They want something which is fast, has nice animations, has nice styling, and to achieve that in a cross-platform manner without a single way of presentation would be extremely hard. And UNO luckily overcomes this issue with one XAML dialect that runs across all the platforms. Third point is to let views do views. And by that we mean that UNO platform is using MVVM design pattern, which allows us to create a view that's decoupled from a view model and business logic. And we can just switch up the view as we want. We can even create separate views for each platform if we want to, and it will still work perfectly, and we don't have to change anything from the business logic side and the view model side. Everything works through data binding, so data binding and xbind from UWP is supported in UNO platform as well. UNO platform has also native interoperability, so you can reuse your existing native UI controls inside UNO application, just as you would drag and drop it into XAML. So you can just take UI button from iOS, put it into XAML, and it will work on iOS. In addition, you can also achieve interoperability with Xamarin.Forms if you want to. Finally, UNO, for UNO, performance is a feature because users will not saddle with a slow application which is lagging, and they want it to be fluid and fast and performant. So performance is very key. The architecture of UNO looks like this. So we have 4 platform heads at the top, which is Windows, WebAssembly, Android, and iOS and Android. Underneath that is your application code, which is written in XAML and C#. And then each platform is different. So in case of Windows, your code is running directly against Windows APIs. So there's no layer of indirection. You are just running directly against Windows, and so the performance is perfect, and there is no change, no difference from how you've been developing UWP applications before. In case of Android and iOS, there is UNO underneath, and it renders the controls using UIKit for iOS and Android UI for Android. And underneath UNO, there is Xamarin, and everything is running on Mono. Xamarin provides the native bindings for the platform-specific APIs. Finally, for WebAssembly, UNO surfaces your XAML or renders your XAML using HTML and CSS and uses some JavaScript to do that. Underneath UNO is then again Mono framework that's running in the browser as WebAssembly. As I've mentioned, UNO is striving to achieve 100% compatibility with UWP XAML. That means that things like data templating and styling, animations, Visual State Manager and adapted triggers, data binding and xbind, shapes and brushes and image brushes, and all these things that you expect from UWP application, you will get in UNO as well. In addition, you can use conditional XAML to create specific UI for specific platforms, or to create, to include some platform-specific UI. And finally, you can use native controls embedding. So that's what I've talked about. You can embed native controls like UI button into XAML. But UNO doesn't stop there. It's not only about the UI, it's about access to more APIs like geolocator, speech recognizer, clipboard, and application data. All these APIs are available and are implemented by UNO with the same interface as you expect on Windows. So there is no change. You have your UWP code done, and it works the same on all platforms. UNO platform has some prerequisites. If you want to use it, you will need Visual Studio 2019 or 2017 for Windows with the following workloads: Universal Windows Platform, mobile development with .NET and ASP.NET and web. You will also need a macOS device to build your iOS application, and to make your development experience as smooth as possible, I recommend you to download the Visual Studio extension UNO Platform Solution Templates. And I will show you how to quickly build a Hello World application using UNO. So I will go into Visual Studio and first show you how to get the extension. You can do it here in the extensions menu. You click on Manage Extensions, and in the Online tab you search for UNO. And as you can see, there is UNO Platform Solutions Templates extension, which you just normally install as any other extension, and you will be up and running. So now I will create a new project, and in the search box I will type UNO, which will give me two different templates. One is cross-platform library, which is for UNO-based libraries, and then cross-platform application, which I will choose and create some basic application. I will call it Hello UNO and create it. That will take some time, so we'll wait. It's basically creating the platform heads and a shared project in which the shared code is going. So once it loads finally, I'll collapse, and here you can see that the solution contains Android, iOS, UWP and WebAssembly project, and I'll first set UWP as the startup project and use local machine to run it. And in a few moments we should see our Hello World application. So that's a normal UWP application. It works just as normal window and it says Hello World. And how does it work? So if I check the UWP project, I can see that there is no app.xaml or mainpage.xaml, which is unusual. But once I go to the shared project, these two files are there. And once I open, for example, main page XAML, you can see that's the normal main page you are used to from UWP. As you can see, the XAML designer is not working just now, and the reason for that is that Visual Studio is has usually problems when you first create the solution and you have to unload the UWP project head and reload it, and after that the XAML designer should boot up. So here it is. So that's the normal XAML designer. I can go into code and add some slider with name slider, and I will also add a text block which will use data binding to slider with path value. So this text block will show the current value of the data of the slider above it, and just to make the application look right, I will use stack panel as the root element and add some padding, for example 30. So that's much better now. Okay, if I will run it again, and the result should be a classic UWP application with data binding. Nothing too surprising, yeah. But what now happens if I select the Android project, set it as startup project, and run the application in emulator? Okay, this will take some time. The application is now running, I think, or isn't it? Yeah, that's not the right application. Just a second. And it's here now. So that's the same UI running on Android. And as you can see, I can slide and the value changes as you expect. It's fully working XAML application on Android. Of course, orientation as well, and everything you expect from normal Android application works as well. So I will now stop debugging and switch to iOS. For iOS, I will have to pair to my Mac because it says disconnected. So just a moment. And of course, there seems to be a problem, but now it's better. So just a moment. It's starting the debugger on Mac, starting the build agent and initializing the environment. So that's done. And I will run it on iPad Air. So let's wait a moment. So this is the iOS remoted simulator, which is remoting the simulator from Mac to Windows. And this problem has been appearing now in the latest release, so I will just rebuild and run it again. That should hopefully help. And no, it didn't. One more try. Rebuild. Let's stop this and try again. But it seems the demo gods don't like us. So luckily I've prepared a video with the debugger on iOS. So I will just show you in the video and you have to trust me, it works. So there's the same application again. And in the simulator you can see it installed correctly. And once it loads, there is the same UI again running on iOS, and data binding works and everything else as well. So that's for iOS. And finally we go to the most amazing part of the UNO platform, which is WebAssembly support. I will start this in iOS Express. As you can see, the WebAssembly project is again completely empty. There is just program CS which launches the Windows application. And once it loads, we will see take some moment to attach to the debugger, and we should see the same UI again. Yeah, that seems it's finished now. Yeah, that's great. So we have the slider, data binding, and everything running in the browser directly on the client. There is no server-side component needed. This is pure WebAssembly in the works. And I will just show you as a proof that there is no network communication going on. It's all running directly in the browser. And you, as a proof, also you can see that the browser downloaded Mono WebAssembly, and then our application as WebAssembly, and then a lot of .NET components and dependencies. So this is pure XAML project running in the web browser. So that would be the first demo, and I've prepared also a more advanced demo here, which will demonstrate not only the basics, but also things like styling, templating, and adaptive triggers, which is a very nice capability of UWP XAML. So this basic application contains a button, which is now retemplated to use to, instead of as a button, UWP button, display as a border with a text block, and it has background. The background of the border is bound to the background of the button. There is also a click handler, and this definition is pretty simple. It just generates a random color and sets this color to the background of the button. That's here. The next part of the application is a list. There are two components here. There is list view, which displays items from the page. These items it displays in a list-like presentation, and uses linear gradient brush as the background of the items. And yeah, there is also a grid view, which displays the same thing but as a grid, and it uses different presentation, different colors as the background. So this pretty much demonstrates all the features of UNO in XAML. It also contains this visual state manager, which uses adaptive trigger, and it will hide the list view when the window is wide enough so that the grid is displayed. So on phones you will see the list, on bigger displays like PC you will see the grid. So let's demonstrate this first in UWP, because that's the native application. And then we will be able to compare the behavior with others. So as you can see, we have normal UWP application, selection in the list works, and when I click the button, it changes color. And when I resize the window, we now have list view instead of grid view. So that's very nice, because you can adapt to the size of the display and your application will always look great. You can also notice the slight gradient in the background. So let's see how the same thing looks on Android. So for Android, for some reason we've lost the emulator. It is not convenient at all. Let's try again. And it's not displaying. But once again, I have already prepared a video so that I can avoid these issues. So nope. Here we have the Android application running in emulator, and as you can see, it will run very soon. And it's the same UI. You can notice the rounded corners, the selection works, and when I tap the button, it changes color. When I change orientation, you can see the grid view has now transformed itself into a list view, and we can see the list of items. And if we change back, we get a grid. So that works perfectly. And I will now probably skip the iOS test as well, because it will probably not work because my Mac is not communicated with me tonight. So for iOS, this is the application running on iOS. And in a few moments, we will see the same UI. Again, here is the list because the narrow size of the iPad is narrow enough. And the button works. And when we change orientation, from the list now is a grid, and the selection support works. You can see the rounded corners. Everything looks the same as on Android and Windows. So that's for iOS. And I will now at least demonstrate the WebAssembly version. And the WebAssembly version will again run in the browser. And in a few moments we should see the same UI again, running by virtue of JavaScript, HTML and CSS rendering. So that's our application. Selection works, rounded corners are here as well, and clicking the button changes the color. And now I will just change the size of the window, and once it refreshes we have the list. Now again showing the slight gradient brush in the background, and everything works just the same as in UWP. So that would be it for our demo, and I will return to my presentation to show you a little bit about how these things are implemented. So how does it work? Uno exposes UWP types and members and exposes them with the same namespace, and a subset of them is implemented by Uno. Any existing C# UWP code will compile against Uno, and if you use some API which is not implemented or not possible to implement on some platform, you will be informed about that during runtime by virtue of a not implemented exception. That would not be as convenient as you would expect, but luckily Uno platform comes with a Roslyn analyzer, which makes sure that it will mark the APIs which are not available on some platforms with a blue squiggle, and you can then see which platforms you need to implement yourself, or which features you have to disable on specific platforms. So you are not limited, you always know what's going to happen, and you don't need to be afraid of some runtime exceptions because of some APIs are missing. Uno namespaces are mapping directly to UWP namespaces. This is the cornerstone by which the whole system works. Because if you use a Windows UI XAML controls button, there has to be a Windows UI XAML controls button in Uno platform as well. And when you switch the runtime assembly against which the application is built from Windows Foundation Universal API contract on UWP to Android, iOS and WASM Uno platform DLLs, it will work just the same. You will not have to change any code. And instead of Windows controls and Windows APIs, Uno will provide those for you. So the whole magic works through mapping the native UWP APIs to some native APIs on other platforms. So if you have a text block, you will get a UI label, text view or paragraph on other platforms. And for application data settings, you will get any NS user defaults, share preferences, and IndexedDB. So underneath, UNO is still using native APIs and native controls, but it's very nicely wrapped and you get access to all the features that you would normally get in UWP. And you just write your UWP code and you can just run it then on Android, iOS and WebAssembly without many changes. And as long as you are using APIs which are implemented by UNO platform, you are okay and you don't have to do anything. Another key part of UNO platform is XAML code generation, which takes your XAML markup and translates it to C#, which is then compiled into the assembly. You don't have to be afraid of this weird looking code at the right. This is just machine generated and you will never have to deal with it at all. It's just for the compilation and you will also always keep writing just the XAML code, and this is just what UNO platform is doing for you behind the scenes. And to just show you the solution of UNO platform, I will give you a peek under the hood. So this is the solution of UNO, and the main part of the solution is here in the UNO UI folder. There is UNO project and UNO UI project, and these are those that implement the specific Windows APIs. To make sure that all the interfaces and classes are available in UNO, the team has built a UWP scene generator, which is a console application which takes as input the Windows API contracts and checks if those are implemented in UNO, and if not, the tool generates a stub class which contains not implemented markup for all those classes which are not yet implemented. We can see that in action, for example here, in the generated 3.0 Windows application model chat and chat message manager. We can see that this class has been implemented for Android and iOS, but many features are not available on any platform except for this show compose SMS message async. And this is still not implemented on desktop, .NET 4.6, which means WPF, WebAssembly, and macOS. But it is implemented on iOS and Android, which is denoted by this false here. And the implementation then looks like this. So it has this directive, which says it should be compiled only for iOS. And it implements the same method, show compose SMS message async, and implements it using platform specific APIs. In this case, for iOS, it's MF message compose view controller, creates a message and shows the controller to let the user send SMS message. On Android, you get again a very similar thing, the show compose SMS message async method, and inside that you are using native create intent API, which creates specific intent and creates the activity which then runs and shows the specific URI. Some simpler APIs, like the launcher, can be implemented in just one file. So here's launcher from Windows. It has launch URI async method. And this is a specific implementation for each platform in one file. And if you choose the target platform here, for example iOS, you will now open the URL in UI application shared application API. when you choose Mono Android, you are using intents, and in case of WebAssembly, it's invoking JavaScript code, which is then implemented here using TypeScript, and it's just opening a new window with the URL we have chosen. So that was a peek under the hood of UNO platform, and I will return to my presentation to finalize it. So there is one more thing I would like to mention. There is some support for third-party libraries. To implement library support for UNO, you have to basically target a new platform, because UNO requires some changes to your code. But UNO platform team has already provided forks of many existing libraries like Windows Community Toolkit, Prism, Telerik UI, Windows State Triggers, and more. So you can just use those forks, and there is a plan of doing a pull request back to the original repository and adding the UNO platform support there directly. There is also experimental Lottie support, and I can show you that in the browser. Lottie animations are pretty cool, and as you can see, thanks to UNO platform, you can run Lottie animation in the browser. So as you can see, it runs pretty nice, 60 FPS, and it can even run backwards. If I do it right, here we go, it goes backwards, and it's all supported, so you can now add your Lottie animations into WebAssembly. And I've talked a lot about WebAssembly because WebAssembly is the key differentiator of UNO platform against other cross-platform application development frameworks. UNO is a full-featured WebAssembly UI framework, and I highly recommend you to watch the Microsoft Build 2019 session with Jerome Laban, who is the inventive CTO, and he talked there about WebAssembly in general, and the talk is very interesting, and I very much encourage you to see it, because it's a very nice peek into the future of web development and maybe application development in general. Finally, if you want to play with UNO platform without installing anything, you can do so as well, thanks to the UNO platform playground, which is a application which is built with UNO to demo UNO. And this application is available for the web browser as a WebAssembly app, and you can also download very similar application for Android and iOS from the App Store, and here are the links to that. You can also scan the QR code, it should take you directly into the store, and you don't have to worry, all these links are also included in my GitHub repository for this talk, so you can also find them later if you want to. I will just show you quickly the playground. So this is full-featured XAML editor running in the browser. You can see things like buttons, and you can change everything at the right runtime. So if I change this to test, you can see test here. I can change the button and make it 400 wide, and so on. So you can really play with UNO platform right in the browser without installing anything, and you can try out how everything works and behaves. As you can see, there is a lot of samples, and you can just freely edit the XAML editor and also provide your data in this window as a JSON. So finally, a call to action. I highly recommend you to download the UNO platform extension for Visual Studio and create your first app with UNO. You can find a getting started guide on GitHub of UNO. That's the second link on the left side. And you can also check the official website of UNO for more resources, samples, and showcase of UNO. Secondly, I encourage you to submit feedback and contribute, because it's an open source project, so every feedback, every issue, every bug is welcome. And if you want to add some new features which you are missing, you are also free to do so. And to get started with that, I have written a 3-part blog article, which is the 4th link on this slide. And this article shows how to get started contributing to UNO. So this final slide just shows the resources, and on this link, github.com, my name and Meet UNO Talk, you can find all the resources for this presentation, including the presentation itself as PPTX and PDF. And also you will find there links to all the samples and also the demo application, which I have successfully or less successfully demonstrated during this talk. Below that you can see a link to my blog, where the contribution to UNO platform blog articles are. And you can also reach out to me on any social network and ask any questions and give any suggestions if you want to. Thank you very much for your attention, and I look forward to see what you create with UNO platform.